Hello and welcome to this webinar on long multiplication in Key Stage 2. So when is long multiplication introduced? In Year 5, children build on their learning of multiplying by a one-digit number and begin to multiply by two-digit numbers. By the end of Year 6, children should be able to confidently multiply up to 4 digits by a two-digit number using their formal written method. So how is long multiplication introduced? In Year 5, the long multiplication method is introduced for the first time, initially using the area model before moving on to the formal written method. Base 10 and/or place value counters may also be used within the area model to help children understand size, scale, and place value. So first, let's take a look at the area model. So if we take a calculation such as 34 multiplied by 23, the first thing we do is partition or split our numbers into tens and ones. So we can split 34 into 3 tens and 4 ones, and 23 into 2 tens and 3 ones. Next we multiply our numbers together. 20 times 30 would be 600. As 3 times 2 is 6, multiplied by 100 would be 600. 20 times 4 is 80, as 2 times 4 is 8, multiplied by 10 is 80. 3 times 30 is 90, as 3 multiplied by 3 is 9, multiplied by 10 is 90, and then 3 times 4 is 12. The final step is to add our answers together. 600 plus 90 plus 80 plus 12 equals 782. Once children are confident with the area model, we can move on to the formal written method. Here we have 41 multiplied by 26. As you can see, our digits have been organised using our place value headings. In this example, the larger value is on top. However, multiplication is commutative, which means if we swap the numbers around, the product or answer will remain the same. Children should also make sure they are placing one digit per square. This minimises chance of error in calculation. Now the first calculation we are going to be doing is 41 multiplied by 6. To begin, it can be helpful to write our calculation alongside our working. 1 times 6 is 6, and then 4 times 6 is 24. And as we have no more digits to multiply by, we put our 2 or 200 straight into our answer box. The second calculation we need to do is 41 multiplied by 20. 2 times 1 is 2. However, as the 2 represents 2 tens or 20, we need to put a 0 or placeholder in our ones column first. Finally, 4 times 2 is 8. The last step is to add our numbers together. 6 plus 0 is 6, 4 plus 2 is 6, and 2 plus 8 is 10, giving us a final answer of 1066. One of the most common mistakes with long multiplication is omitting the 0 as a placeholder. As you can see from this example, 32 times 6 does equal 192. However, on the second row, as the 4 is in the tens column, it represents 40 and not 4. Therefore, we need to add a 0 or placeholder in our ones column. Then we can re-add our subtotals correctly. This would give us a final answer of 1,500. 472. As children become more familiar with the method, we can increase the number of digits and begin to exchange. Here we have 326 times 32. The only difference is we have added an extra column for our hundreds. So first we need to calculate 326 times 2. 6 times 2 equals 12. Here we need to exchange 10 ones for 1 10. 2 multiplied by 2 is 4. Add the 1 would equal 5. Then 3 multiplied by 2 is 6. Now we move on to 326 multiplied by 30, remembering that we need to add our placeholder. 3 times 6 is 18, exchanging 10 tens for 100. 3 times 2 is 6, add the 1 equals 7. Finally, 3 times 3 is 9. The final step is to add our numbers together. 2 plus 0 would be 2. 5 plus 8 is 13, exchanging tens for 100. 6 plus 7 is 13, plus the 1 would be 14, again exchanging our hundreds for 1,000. And 9 plus 1 equals 10, giving us a final answer of 10,432. Finally, a couple of top tips to help you with your long multiplication. Firstly, put the 0 or placeholder in first. Another tip is to make sure your calculation is set out clearly, remembering to put 1 digit per square. Thirdly, remember to cross out any exchanges as you add. Another good tip is to estimate your answer, for example by using rounding. And finally, make sure you are confident with your times tables. This will allow you to concentrate on the method rather than recalling your times tables. Thank you for listening. I hope you found this helpful.